Okay, I'm a little nervous. My English is not so good, but I will present the development of drying technologies using renewable sources in Chiapas, Mexico, a review. And when I say a review, I will mention some of the work I was doing in Chiapas, but also I will mention some of the work from some colleagues in Chiapas. Okay. The sun is our main reserve of energy, and in the world, and it's been so important in our culture. Okay, I would like to introduce myself as an agent of change and a promoter and activist for the renewable energies. And I really love solar energy, so I am glad to be here. I studied renewable energy engineering in the Polytechnic University in Chiapas, where I fell in love with solar energy. And I also was working in a solar company in Chiapas for 5 years. Okay, and I also work or run solar cooker workshop with Red Mere and also by my own. And during my free time, I develop, build and evaluate solar dryers and solar cookers, and also support solar food processing. Okay, from 2007, from 2008, I was a solar thermal installer in Módulo Solar, a Mexican company. And nowadays I work as a solar thermal project engineer in the same company, Módulo Solar. And this company developed turnkey projects for solar water heating systems in residential, and also solar heat for industrial process, hospital, restaurants, and any other sector that need hot water. This is the work that we do in the company. Okay, solar woman. In 2016, I traveled to Mexico City to be trained and to get a competent certification in solar installation of water heater systems in homes. For this system was for homes, and I become part of the solar training woman course. And this project led by German Cooperation in Mexico won a prize in Gender Week in German Cooperation, and naturally born Red Mere. But what maybe you are going to ask, what is Red Mere? Red Mere is a woman network in renewable energies and energy efficiency. And Red Mere purchase woman, that women should be able to contribute to the energy sector with their knowledge and skills in equal condition with men, and to reach their full potential and grow in the pathway. Okay, so thanks for the attention in my introduction, but now we will come back to talk about the solar drying in Chiapas. And I will start to talk about the background and the influences in the design of the solar dryers developed in Chiapas. Cuba Solar presented their experience with other institutions, and here we can see a cabinet dryer in School City, Camilo Cienfuegos. This is we can also see this cabinet dryer in a botanical garden in Cuba. This is also other dryer built in Cuba and reported by Corp Linares in the literature. And Here I want that all of you look the walls of them and the material of this solar dryer. Okay, so this is other dryer that is very similar to the one before from Cuba, and it was built by students from the first generation of my university. They were in their second career year, so the solar dryers are very similar, as you can see. Okay, also we can see this other solar dryer. This is also was built by the first generation in my career, and have two plate collectors to heat the air, one in the upper and other in the down of the drying chamber. All the dryer were displacing in this nice platform of solar devices that was in my university. Also, Berrones and Saldaña in 2009 registered the use of solar dryers for solar drying of Chiapas fresh cheese. Solar dryer was designed by and built by Mojica and Company, and used for the drying test. This dryer corresponds to a cabinet solar dryer with thermal accumulation system. And here we can see the cheese that is being dried. Okay, so now I would like to talk about the Chiapas fresh cheese solar drying. This is the main work that I was doing in solar drying. So I would like to tell about the fresh cheese. What is fresh cheese? This is a smooth flavor and consistency, and this is a double milk white cheese, like little salty and little acid. This is the most common presentation when the cheese is fresh, and in this way, it has a short expiration, and storage in refrigeration is necessary to prevent the decomposition. Okay, but if we remove the water in the cheese, we can obtain a powdered Chiapas dried cheese, and it can be used in many applications like pastries, antojitos, and a wide variety of homemade food in Chiapas. And even when I was in Consulfund 2018, I bring with me some of this cheese and also some of this bread, and some of the people that was there tried the cheese and the bread. But the traditional method in Chiapas is used a traditional method. We use a mesh cabinets to dry the cheese, but the process is very long. It can take from 1 month to 2 months with good climate condition. This is the most economic method and widespread in Chiapas because their simplicity. And sometimes the cheese can just be disposed directly in tables in the house. Okay. But the traditional drying cheese have some complications or difficulties. The community where is located the solar dryer is in a rural area near to a rainforest reserve, and the climate and the humidity and in some period of the year is cloudy. This reason difficult the traditional method, extending the drying time and exposing the cheese to mold, as you can see here. Okay, this is our solar dryer. This is a cabinet solar dryer with a detachable structure with forced circulation about 3 by 1.5 meters. The dryer was installed in UNESCO community and municipality of Cintalapa, Chiapas. It was operated by the habitants 10 years. Okay, now I would like to mention most of the parts of the solar dryer. This is the collection system that is a triangular head air collector in the upper part of the chamber. Okay, the cover glass retain the heat in the heat air collector. The corrugate absorber plate is the one that we can see here and is formed by undulate metal sheet. The flat absorber plane is formed by a metal sheet too. And here we can see the drying chamber and the trial race and the tries when we dispose the cheese. The extractor or the fan, it helps to remove the heat air from the air collector in this place and push into the dryer in the lower part. Okay, this is the dryer structure as I mentioned. These need to be disassembled to transport in remote rural areas. These are the panels, and now as we see this material again, like the Cuban dryer that I showed before. This is called multimuro, and we use here in Mexico, and have the advantage that we can unit the part of the metal sheet, of the metal panels. This is the ventilation and allow to escape the humidity in the chamber. Here also we can see the parts of the collector, the collection system, the glass cover, the corrugate. This is one. The corrugate absorber plate, the flat absorber plate, the fan, the trial race, and the chamber, and the structure. And as I was mentioning, the fan produces the circulation of the hot air. And here we can see how the circulation between the air heating chamber and the solar dryer chamber is established. And the fan extracts the air and push into the bottom of the drying chamber. And it's like a cycling process, and that's why the dryer function, because we heat the air with the sun rays in the collection system that is in this upper part. Okay, and also we make an evaluation of the solar dryer, and we measure some atmospheric parameters like solar radiation, temperature inside the chamber, ambient temperature, and relative humidity. Also we measure dryer operation parameters like humidity and temperature inside the drying chamber, temperature in the two absorber plates, and temperature in the collector chamber. And as you can see, we had a very poor method of evaluation, but we make some measurements. And as you can see the graphic, this is the humidity. So this is the ambient humidity, and this is the humidity in the chamber. So we have a big differences in between the two humidities. The relative humidity in the chamber was between 9 and 15%. And also here we can see the temperature in the dryer, but the most important is this red line that show to us the temperature in the drying chamber. And as the graphic shows, the humidity in chamber is less than the ambient humidity, and the temperature in the drying chambers can rise up to 15 centigrades. And these conditions allow to dry the fresh cheese in half of the time compared in traditional method, and adding in addition to improving hygiene conditions during drying. This equipment has 9 trays. Each one can hold 18 cheeses, which allows drying 162 cheeses per batch. Okay, and this is a great project because the solar dryer is an opportunity to preserve the cheese in times of abundances of milk, and obviously the milk halving in price and represent an economic advantages for producers through various savings, since even they don't need to sell the fresh cheese, and they have the possibility to keep it and sell them later as a dried cheese. Okay, after I finished my university, I studied a master degree, and then I uses this project, this dryer, to elaborate my thesis project, and also I presented this. I make a poster presentation in console food in Solar Cooker World Conference in 2017. And for me, it was amazing to participate in this project, and I believe that was a successful approach to introduce solar technologies to this process. Okay, now I would like to talk about the solar dryers 2 cubic meter for rural communities. This also was some solar dryers that we developed when I was in Chiapas yet in this Chiapas solar company. This is a cabinet dryer with a detachable structure too, and with a forced circulation of 2 cubic meters. And the collection system is in the upper part of the drying chamber. And as you can see, it's very similar to the cheese dryer, but little bit smaller. And it also have a triangular heat air collector, and the same parts as you can see: glass cover, corrugated absorber plate, flat absorber plate, the triangular air collector, and the other parts. This is the door of the chamber, the metal panel, and the trail race. And here we can see how the circulation between the chamber, the collector chamber, and the dryer chamber produce the circulation of the air. And this is like the fan. The fan push the air dryer and make this cycle. And as we can know, the solar radiation heat the air in the chamber of the collector. Okay, this is another diagram of the triangular flat plane of the triangular air collector. and it have a flat plane absorber and a corrugate absorber, and the circulation occurs because we have these gaps. This is an example of the solar dryer installed in a rural community called Villa del Rio, and with other renewable energy sources too, like a 10 kilowatts panel PV system, and also have 2 wind turbines, but I don't add the pictures of the wind turbines here. And we can see here the solar dryer and some of the inhabitants of the community, and here some of tests of drying apples. Okay, now I would like to talk about solar thermal wind hybrid dryer. This dryer was manufactured by the company that I was working, Chiapas Solar, but also was the thesis from a colleague, Guadalupe, and she make all the design and the study of the solar dryer, and I was involved in the construction. Okay, why we propose this kind of solar dryer? It's necessary to increase the quality of solar food, and to reach that is required to maintain the most important the operation parameter, that is the temperature. So I need a constant temperature to obtain a good quality food products. As a solution to the sun intermittency, and to maintain a constant temperature, we propose as auxiliary system with backup. And we propose a solar thermal system to main resource and the drying process and electrical heat backup of powered by a wind system, as you can see here. How it works? Okay, the collectors capture the radiation for heating in a fluid with each storage in this thermal storage tank. And we have also an interchange, a heat interchange, and then the water is heating here, almacenate, and then running to this circuit with a pump, and we transfer the heat to the dryer chamber with this system. So it's an indirect system. Here we have some of measurements of the solar heating, the solar dryer. This wind thermal hybrid solar dryer. And okay, in the graphics we can see we show the temperatures in tank water. These are the temperature in the tank water. And also we have the temperature in the chamber, that is the black line, and we have the temperature, ambient temperature. So as we can see, we can maintain the temperature constant, and also in this case for 16 degrees, and here we have 17, but maybe here was a little cloudy, and that's why the temperature in the solar tank reduce the temperature, but we add the heat necessary to the process with an external resistance. And here we can see the humidity in the chamber. So always the humidity in ambient humidity was higher than the chamber humidity, and these conditions allow to dry several products. Okay, and this was a paper that we made with some colleagues from the university, and was published in a Mexican journal. And here we make the simulation of the drying process, and we try to fit some equation, Newton, Page, and others to the data. So here we can see the reduction of the humidity, and in this case was a moringa. Moringa is like a plant, and we measure the mass, and with that we calculate the loss in humidity, and then we fit the curve to some other equations, and to obtain some parameters of the drying process. Okay. I will also like to talk about the solar dryer for rural communities. That was the last work that I did when I was in Chiapas. This solar dryer is also a cabinet solar dryer, and is very small compared with the others, and have a fan fitted by this PV panel. This was, we built and delivered 12 solar dryers from 1 cubic meter in several, in three rural communities in the state of Chiapas. And here we can see some of the pictures during the process. Here is my little son that he is always involved in the projects that I do. And here we have in a bus all the dryers, and here we are delivering the dryers into the communities. Okay, I will like also to mention that nowadays I am working in a solar dryer, but this dryer was inspired by the work from other colleagues too. This is a cabinet solar dryer, but it's from a different material, as you can see. This is also an inspiration of solar drying that is called La Sazón del Sol, and they are doing a lot of work in the solar drying process. This is the dryer that I am working, and this is from wood. And I would like to present, okay, this is my presentation, but I have some minutes, so I would like to mention some of the conclusions that I have about this review, the drying technologies in Chiapas. Okay, so we can see that the dryer was evolutionating from metal dryers, and the first one was bigger, and the second was a little small, from 2 square meters. And I think that these kind of dryers are good, but we have some inconvenience, because the price of the solar dryer is a little expensive. Maybe the price of one of these dryers is maybe 40,000 pesos, so it's a little expensive. And I would like to say that this dryer was successfully implemented, but because the dryers have some economic support. In other case, it's hard to introduce, or hard to sell this dryer to rural communities. And I think it depends of the product, and it depends of the technology we can use. I mean, this dryer is very specialized, because have a wind turbine, have a thermal storage, have a heat exchanger. So this kind of solution that resolve to maintain the temperature permanent, but the problem is the high cost. In contrast, I think these kind of solar dryers are also very good for drying, and it depends. If we need to dry some products that we can have in home, or if we can have dried vegetables or fruit in home, we can use a smaller dryer, even smaller than this one. And but if we dedicate to produce food, and we have a lot of production, and then we need maybe a dryer more sophisticated. But I would like to invite to all of you to use a dryer, because we can do a good things. As an example, maybe I can mention that I always have lemon and ginger dried in home, and we use in several teas. So this is my presentation, part of the work that was developed in Chiapas, and I really would like to continue working in solar dryers.
Thank you so much.